Alright, we're back. This will be day 2 of testing, and it's going to start with Chapter 5 Trig topics, which are the newer Trig topics. So, the formula sheet has all these identities on it, and you have to know how to use them. There's a lot of identities on there. So this first one, 2 sine 6x cosine 6x. This is the double angle formula. So, on my formula sheet, I noticed that this is emulating this formula. So it's sine 2 theta. If you could figure out who theta is, you're good. So the angle that they start with is 6x. So plugging that into our formula, that would be sine of double 6x, which is 12x. And that's my answer. There's no more evaluation after that because that's obviously not something we know. So 2 cosine squared 3 theta minus 1, that is cosine, that's the double angle for cosine formula. So this is this guy, as long as you can figure out what the angle is. So this is the original angle, and you're supposed to double it. So for us, that means cosine of, instead of 3 theta, doubling that would be 6 theta. Again, can't really do any more work with that one. Alright, moving along. I'm sure we'll have to come back to that reference sheet in a moment. This is your yellow reference sheet, by the way, but you will get a new reference sheet during your testing. We use the sum and difference identities to expand. Cosine of a difference. So what I'm going to do is I'm going to first write out the expansion formula with a's and b's. So it's cosine, cosine, plus sine, sine for a and b. So now, this is a and this is b for our formula. So I'm going to write cosine x times cosine of 3 pi over 2 plus sine x times sine of 3 pi over 2. And then I have to go through my unit circle and figure out that cosine of 3 pi over 2 is just a 0, and sine at 3 pi over 2 is a negative 1. So this term completely cancels out, and then you have sine times negative 1. So this simplifies to negative sine x. And then we have an added issue here, because now they want you to circle everything that is equivalent to that. So for a lot of kids, they circle this, and then they're done, and they walk away. But you have to remember that the sine function is odd, which means this negative can also be inside of your sine function, like this. So odd functions, when you have a negative input, it could be rewritten as the opposite of that function with a negative in front instead. So these mean the same thing. That's a tricky property, but I will tell you that if you remember what happens with odd functions, and the other one you should probably think about is what happens with even functions. If it's cosine of negative x, that's the same thing as cosine of x. So maybe just quickly study these before you take your second day of testing and make sure that you remember which one's which. Alright, using the sum and difference formulas. Alright, so we have 2 different angles, alpha and beta, which you can call a and b if you don't like alpha and beta, and you have to fill out their ratios. So first thing I'm going to do is run through and give all the missing sides. So this is a 25, and let's see, this would be a 12. So when I go to set up sine for alpha, sine would be 7 over 25. Cosine of alpha is negative 24 over 25. Over here with beta, sine of beta is 5 over 13, and cosine of beta is 12 over 13. So now that we have all of the sines and cosines for alpha and beta, we're going to use our trig identity, and the first thing I want you to do is write out the formula from your formula page. So sine of alpha minus beta is, I'm going to use a and b because you guys hate alpha and beta, so sine, cosine, same sign, no. Sine, cosine, cosine, sine. There we go. So, using that identity, and then plugging in the new ratios we just found. So like for instance, sine of a, you just found to be 7 over 25, times, excuse me, cosine of beta would be this guy, 12 over 13. And then a minus, and then cosine of alpha over here is negative 24 over 25. And then sine of beta would be this guy, 5 over 13. And we very carefully type this in our calculator. Math enter to get back to a beautiful fraction, and I never did that. So let me type that in real quick. 7. Negative 24, 25. Alright, 204 over 325. Unless I typed wrong. I don't know. Alright, that's what I got. And that question was on a test quite a while ago. Some of you weren't really sure what to... You could find the formula okay, but you weren't sure what to do after that. So there's a question just like that on your post-test. So let this be your moment to shine, guys. Alright, we're solving a more complex trig equation here. So it is definitely looking like a quadratic, which means we want to factor it. There's no common factor, but it is the reverse foiling kind of factoring that we are used to. So 2 sine theta, or 2 sine x would be, squared, excuse me, would be 2 sine x times sine x. And if it bothers you that there's sines, you can just go back and rewrite it like a traditional quadratic. And then think about how you would have factored that quadratic, and then instead of just having x's, put sine functions with them. So multiplying to -1 on the back end, that means we need positive and -1. So let's put a -1 here and a positive 1 here, because that'll give me -2 sine plus 1 sine for the middle term to be -1 sine. And then we're going to solve. So each factor has to be set equal to 0. So for this first one, 2 sine x plus 1 equals 0 will give me sine x equals -1/2. And then the second one gives me sine x equals 1. And I just want, through one revolution of the unit circle, where is this true? So sine is -1/2 a few places. Let's see, that's 7 pi over 6 and 11 pi over 6. And then sine is 1 at pi over 2. Alright, moving along, the next question, more trig. So here we have to work through our identities. And 1 plus cotangent squared we can trade out for, and I always forget this one, so even I have to look this one up. Where is it? There we go. It's cosecant squared. And then sine squared we'll just leave for now. Cosine squared we'll leave that for now. And secant I'll go ahead and trade for a 1 over cosine. Now while I'm at it, forget cosecant squared. Let's call that 1 over sine squared. Alright, that was a little bit sneaky of me. But now we have one big fraction set where things can cross cancel. So sine squareds are going to cancel out, and then be careful here, 1 cosine will cancel. So all we have left is cosine theta. So that was a game of choosing the correct trade, and then sines and cosines are where it's at when you get to the identities and you're trying to simplify. Alright, lots of reference sheet material on the conic sections. So parabolas, ellipses, hyperbolas, and circles. So, our first question on our review asks you to identify what type of conic it is, because you're going to write it in standard form. So standard form would be the horrible conic form that we have, and this is clearly going to be a parabola because there's only one component that's squared, which is the x. So, on my formula sheet for parabolas, if the x is the one that's being squared, I'm just going to copy it off of here. This is the standard conic form, x minus h squared equals 4p times y minus k. So basically, the x squared business has to be by itself. So there is no other x term, so we're not going to have to do any completing the square, but everything else needs to move. So x squared equals, this is now -2y minus 10, but this is not looking factored yet, so we're going to factor out the -2. And when you factor out a -2, now you have positive y and a plus 5. So that is general conic form, or standard form, excuse me, right there. And then they want to know what kind of conic it is, and that's clearly a parabola. So no need to complete the square on that example, that was nice. And they don't even ask me anything more about the parabola, so that's even better. So this is clearly an ellipse. If it's the fraction ones equaling 1 with a plus sign in the middle, then we have an ellipse. So the center is located at HK, with built-in negatives here, so positive 3, negative 2. And then they're going to want you to find some vertices and covertices, and also Well, actually, you know, it doesn't say covertices, so let's just find the major axis vertices, and then the foci. Maybe off to the side here, I'll find the covertices as well, but you guys know me, I don't really do the formulas for the covertices and vertices, I just look at the graph. So the center is at 3, -2. And then the value for A, which technically is the larger one for an ellipse like this is going to be a vertical ellipse. So the value for A is, let's see, 4. And then the value for B is 2. So in the vertical direction, you're going to go up 1, 2, 3, 4 units, and down 1, 2, 3, 4 units. And then in the horizontal direction, you're going to go right and left 2 units. And then I'm supposed to draw an ellipse in, but you know how that goes. So finding the vertices, I already see where they're located. These are those blue points that I graphed. That is 3, 2. And also at 3, -6. The co-vertices, if you want them, are going to be at 1, -2. And 5, -2. And yeah, you have formulas on your blue sheet that can find the covertices and vertices for you. If you want to use those formulas, you sure can. You're going to write down, this is h comma, oops, no it's not. Oh yeah, it is. Abruzzo. Get your right formula. There we go. The formula that we're supposed to use for vertices is h comma k plus and minus a. And then for covertices, it was h plus and minus b comma k. So that's that formula. This is this formula. And then the foci. That I am going to need to do a little bit of work for because I need to figure out c. Well, for an ellipse, c is the square root of a squared minus b squared, which is straight off your formula sheet. So that's the square root of 12, which is 2 squared to 3. So the foci formula for the vertical ellipse like this, reading off my formula sheet, it's h comma k plus and minus c. So for us, I have no problem with you starting off with that and saying it's, let's see, where's h? 3 comma k plus and minus 2 squared to 3. And frankly, I'm okay if you just leave it like that. Alright, that was messy. A lot of gross writing. Sorry about that. Alright, so here we're going to create an equation for a hyperbola, and they're going to give me some clues. So the hyperbola has vertices at 3, 0 and -3, 0. Has asymptotes like so. And in order for me to determine what kind of hyperbola we have, I have to graph something. So 3, 0 and -3, 0. This hyperbola is going to do one of these. So we have a horizontal hyperbola, if you want to think of it that way. So what I'm going to do is I'm going to take my formula sheet and I'm going to write down what I'm working with here. So this is the x minus h squared over a squared minus y minus k squared over b squared equals 1. And the center is going to have to be in the middle of those, so it's at 0, 0. The a value and b value are going to be determined because of the distance to the vertices, but also this asymptote equation is going to help me out. I know that the distance to the vertices on a horizontal parabola like this is h plus a. So I see that it's 3 units in each direction from the center. So that means a is 3. And the formula for the asymptote is b over a. It's plus and minus, but it's b over a. So if a is 3, that means b is 5. That's an unreduced asymptote coefficient. Sometimes you have to reduce them, like there's one in another review packet where it's been reduced and it's a little tricky. The one on the test I think is real nice where you don't have to do any reducing. Which direction does it open? You can say horizontally. If you want to say right and left, that's fine. And now I want their equation. Alrighty. So we have x squared over a squared, which is 9, minus y squared over b squared, which is 25, equals 1. Didn't have anything to do with the foci, so I did not bother to find them. Oh, I love this question. So 2 parabolas. One's graphed, one's not. And you know me, I love graphing. So I just need to see a picture, guys. It's just, that's what I need. So the vertex is at 1, -3 for this guy. And if it's y squared, that means it's a horizontal parabola, and the 4p value is positive, so it's going to do one of these. Okay? I don't know in great detail what that looks like, but that's enough to get me going on this part of the test. So, the first question says, Which parabola has a vertex with a greater y value? Well, this guy's vertex is at 3, -4. So his y value is -4. This guy's y value is -3. So B has the greater y value for the vertex. The next question says, which parabola would have a focus with a greater x value, so further to the right? So visually speaking, like this dude's focus would be right there. And this guy's focus is going to have to be somewhere along this line, right? And I don't even have to calculate it, but I know it's at 3 units to the right. And do you remember where this ordered pair was? This is at 1, -3, so it's 1 unit to the right. Ooh, you know what? This is a bit of a bummer. I think I actually do have to calculate the focus. This guy's focus. A bummer. Alright, so the calculation for a horizontal parabola's focus is h plus p, comma k. So this is 4p. So 4p is 1/8, which means p, is 1 over 32. So h, okay, I guess I don't have to do too much work here, guys. 1 plus 1/32 is 1 point something really tiny. So his focus point is little past 1. And this guy has a focus point at 3 comma something. So parabola A has a larger x value for the focus because, and then at this explanation you could tell me that parabola A has a focus of, 3 comma something, and parabola B has a focus at 1 and 1/32 comma something, and clearly 3 is larger than 1 and 1/32. A lot of different ways you can answer that, guys. You can tell me visually speaking or formulaic. I do not care. I'm going to pause for the pledge in a moment. So this next question, we have to do some algebra work to complete the square to find the center and radius of our circle. So I start by collecting all the x's together. Oh, this one's nasty because it's a fraction. Alright. Whatever. Alright, so something's going to go there. And then same idea for the y's. Collect those. And we will complete that square. And then, I don't know why I have a random parenthesis here. We're not ready for that yet. This constant that already existed, I'm going to move it to the other side, and then we have to remember to balance. So whatever we put blue and red have to come over here as well. Here we go. Half of 9 squared would be like 9 halves, so 81/4. Half of this squared would be 25. So, let's see here. Oh, I don't feel like doing fraction work. I think I already answered this one. So this one factors into x and then minus 9 halves squared plus, this is y plus 5 squared, equals, and when you add all this up, I think you get 185/4. So that is your equation in standard form. The center is located at hk, so positive 9 halves, comma, -5. And the radius is the square root of this number, so it's the square root of 185/2. Now typically the radius comes out prettier than that, but whatever. Moving along. What kind of conic do we have here? Well, that's clearly a hyperbola. Oh my gosh. Need to be done, I guess. Alright, so here, for hyperbolas, order is important as far as like who's A and B, because it's subtraction, right? So if it's written in this order where the x term is first, that means you're going to have a horizontal hyperbola where this is a squared. So a must be 2, and this is b squared, so b must be 6. So, oops, I could have put that right there, I guess. And they want to know the eccentricity. So remember, eccentricity is c over a. And I know that the eccentricity on a hyperbola should be greater than 1, but I still need to find it, exactly what it is. So the eccentricity, I just need c, right? So the formula for c on a hyperbola is square root of a squared plus b squared. So what's that, square root of 40, right? So 2 square roots of 10. So the eccentricity is 2 square roots of 10 over a, which is 2. The 2's would cancel, and you get the square root of 10. I really prefer that you guys just leave it as a radical like that. If you write the decimal, that's okay, but obviously the square root of 10 is greater than 1, so I feel like we did something right. Oh, series and sequences. Got lots of formulas on your formula sheet, don't you? So here we need the explicit and recursive formula for this arithmetic sequence. And I know it's arithmetic because I see the pattern is that we are subtracting 50 each time. So the common difference is -50. First term is clearly 220. So the explicit formula for arithmetic starts off with, not that, 220. And then you're subtracting 50 for every term, but n minus 1 terms. So simplifying that expression, let's see, negative 50n plus 270, right? So that's the simplified version of it for the explicit formula. This is the just straight up in the formula example, and then the recursive formula. So I like to start the recursive formula with a sub 1, but it doesn't really matter. The first term is 220. And then every term after that, this is like how a little kid would tell me the pattern. They would tell me, oh, you're just supposed to subtract 50 every time. So for recursive, that means you take your previous term, a sub n minus 1, and you subtract 50. So starting at 220, follow this pattern. That's what recursive means. Find the fifth term of that sequence. So this is geometric, but who cares, because we're just going to plug in a 5. So make sure on your calculator the negative 2 is in parentheses, and then to the 5 minus 1 power, so you can just call that 4 if you'd like, but you do probably want to type that in. Mental math is not always your friend on a stressful situation like on a test. And you get the answer of 64, I think. Yeah, 16 times 4. Alright. Summation this time. So I'm asking for work, and I want to know if it's arithmetic or geometric. So what if you just found the first couple terms? So like a sub 1, a sub 2, a sub 3. And after that, we'll call it a day. So plugging in a 1 into your formula, 3 times 1 plus 2 is 5. Plugging in a 2, so 6 or 8. And then plugging in a 3, you get an 11. So if I follow the pattern here, it looks like we're adding 3 each time. So this series is arithmetic. And then they want you to find the sum. So for me, I love doing sum of the sequence, because then I can just type it in my calculator, especially if you have the newer ones where they just paste everything into the formula. Otherwise, you're going to have to type, 3n plus 2 or x or whatever, and then whatever variable you're using, and then 1 and 5. Now, I know what some of you are thinking. You're like, hey, Abruzzo, you only needed 5 terms, and you only have 2 more left. Just keep going. Yeah, I know. I mean, whatever. That probably would have been faster, I guess. All right, anyways, the sum is 55. Sorry, kids. I'm not always efficient, All right, number 30. Given the first term and the common ratio, I need you to tell me the 7th term. So I feel like that's a bit of a whoopsies. Common difference is what we probably should have said there, because it's arithmetic. So they want the 7th term, huh? I got that. 7th term is first term plus, plus a negative is weird, so let's just write minus 1.5, and then if it's the 7th term, you're going to multiply that 6 times. So this, on my calculator, in one step, of course, because no one wants to think like that, is an 8. Alright guys, almost home free. I love this question. 3 different sequences. Let's check them out. So they want to know, compare the value of the ratio for each sequence. And they want you to rank them from least to greatest ratio. And then explain your reasoning. So let's look at the work here, guys. This is a recursive formula, and the common ratio for this guy is 5/4, which is 1.25. Decimals might be your friend rather than fractions. This one, clearly the common ratio is 2. This one's a bit of a problem though, because we don't have it. So we have the first term, don't know the second term, but I know the third term. So if this is 3 and this is 18.75, and I want you to find the common ratio, you would have multiplied it 2 times, right? So 3 times the common ratio twice is 18.75. So after you divide by 3, which is, I don't know, some decimal, and then you square root that number, you find out that the common ratio is 2.5. So you're going to explain to me how you found each ratio, and then you're going to rank them. So the smallest ratio we saw was from sequence A, the next one was sequence B, and then finally sequence C. So these explanation questions, I mean, you guys are very, very good at explaining things. The more math terms you can use, the better, the more impressive that is. That's, you know what, friends, I think that's it. All right, so that's day 2 of testing. I wish everyone the best of luck, and remember this is a major part of your final exam, so keep keep reviewing.